Assalamu alaikum warahmatullahi wabarakatuh. Student, this is Sir Muhammad Saqib, and we are going to discuss the second topic of the periodic table. So in the last video, we basically discussed about arrangement of elements, and in the arrangement of elements, we had different topics. Like the first topic was about the arrangement of the elements, and in this video, we are going to basically study about the metallic and non-metallic character across a period and how it changes. So just let's jump to the topic. There is a topic: describe the change from metallic to non-metallic character across a period. Okay, and as you all know that we have three kinds of elements. Number one are metals, then we have those which are non-metals, and there are some elements who have both the characteristics of metals as well as non-metals. So they are called metalloids. Okay, so in total we have three kinds of elements. Number one, metals, then we have non-metals, and then we have metalloids. Okay, so now we are going to discuss about those. Okay, and you need to remember name of some group as well in this video. Okay, so from the left to right, in the last class we discussed from the left to right we have periods, and from the top to bottom we have groups, or you can also say from the left to right horizontal rows are called period, and we have 7 period over here, and from top to bottom we have vertical columns which are called groups, so we have 8 groups over here. And from so we are talking about period. Okay, from left to right. So the basically from left to right, the metallic character decreases and the elements change from metals to non-metals. As in period 2, as you can see, lithium is metal as it is left to the periodic table. Beryllium is metal as it also left to the periodic table. But as we go from left to right, so basically the character change from metals to non-metals. As these in the yellow color, carbon, nitrogen, oxygen, fluorine, they are non-metals. They are non-metals. And this one, the beryllium, the boron, this is metalloid as it has both the characters of metals and non-metals. Okay, so I'm going to talk about all those elements, and you just need to remember it with the colors. Okay, so the group 1A and the group 2A, these are metals. These are metals. Okay, group 1A and 2A, they are metals. um, we are not going to talk about group 8. Okay, so group 8 is basically, they are called zero group or noble gases. They usually do not react. The question is why they do not react. So they have already completed their outermost shell, and all those elements, all the other elements, they basically react to complete their outermost shell or to get stability. But the group 8 is called noble gases, and it is also called zero group. They have already gained the ability, the stability, so they do not need to react. So we are not going to talk about this group over here, the group 8A. Okay, so just ignore group 8A for as now, this group. Okay, this group. So I'm just going to remove over here. So we are going to basically ignore this group. Okay, so now group 7A is on the right side and group 1A is on the left side. So on the left side, we have period. So we have metals. Group 1A and group 2A are metals. And group 7A and group 6A, they are non-metals. They are non-metals. Most of these elements are non-metals. Okay. And then group 5A, they are, you can say, non-metals as they are on the right side of the, you can say, periodic table, but they are least non-metallic. Okay. They are least non-metallic. And as I'm going to draw a line, or as you can see, there's a line from started from boron and it goes here. Basically, it is already there, but I'm going to basically make it again for you guys. So this line, the elements, this line, okay, the elements on the left of this line are metals. Okay, the elements on the left of this line are metals, and the elements on the right of these lines are non-metals. Okay, the right side elements on the in this line, are non-metals, and the elements on the left side of this line are metals. But there are some metals, as you can see, they are basically given the color pink. They are metalloids. They are metalloids. They basically linked the metals and non-metals. So they shared the characters of metals as well as non-metals. As you know, metals basically conduct electricity, and non-metals do not conduct electricity. They are purely insulators. But silicon, it is semiconductor. Sometimes it conducts electricity and sometimes it does not conduct electricity. So all the elements on the either side of this line, like we have boron, silicon, and all those, they are metalloids. They are metalloids. Okay. So group 1A, it is called alkali metals. I'm going to write over here. They are called alkali metals. Group 1A are called alkali metals. Group 2A is called alkaline earth metals. Alkaline earth metals. Okay. Group 2A is called alkaline earth metals. Group 3A is basically called boron family, as it starts with boron. Group 4 is called carbon family. Group 5 is called nitrogen family. Group 6 is called oxygen family. And group 7, you can say fluorine family, or it is also called halogen. Okay, it is also called halogens. We will discuss why it is called halogen. Okay, and group 8 is noble gases. We are not basically concerning about this group right now. So on the left side of the periodic tables, we have metals, and on the right side of periodic tables, we have non-metals. Okay, and all these elements, basically they are colored in blue. They are also metals. Okay, because they are on the left of the periodic table. They are also metals, but they are called transition metals. They are called transition metals. We have a separate topic for this transition metals, so we are not going to discuss it over here, but you just have a little bit knowledge about this. So these are called transition metals. So I hope you have understand this, that the left side of the periodic table we have metals, on the right side we have non-metals except group 8A, and we have some metalloids in between group 3, 4, and 5. Okay, so now the metallic character, what is the metallic characters? So metals are basically shiny, they are very conductive, they are very dense, and they are very malleable. Malleable means they can be hammered. Okay, so these are the characters of the metallic. And if I asked you the characters of non-metal, so basically you have to reverse it. The non-metals will not be shiny, they will not be conductive, they will not be dense, and they will not be malleable. Okay, now on the other side, I have already told you, on the other side of this line, you have metalloids which have both the characters of metallic and non-metallic. Okay, as in silicon or boron. Now the elements present in group 1A to 8A of the periodic table are called main group elements. Okay, the elements in the group 1A, there's one group 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, they are called main group elements. Okay, they are called main groups element, and they are also called representative elements. Okay, I'm writing over here, they are also called representative elements. They are also called representative elements. And the other one, this group, these elements, they are called transition metals. Okay, so group 1A to 8A, they are called representative elements, and they are also called main group elements. Between group 2 and 3A, we have some metals which are called transition metals, as I already told you. The noble gases on the right side of the periodic table are in group 8A, and they are very basically, they are not least reactive, they are non-reactive, you can say. Okay, not least reactive, they are not reactive. And group 7A are halogens, and group 1A are most reactive, as halogen is on the right side of the periodic table, and they are the most reactive in non-metals. And group 1A, which is called alkali metals, they are on the left side of the periodic table, and they are metals, so they are the most reactive metals. So if uh, you have been asked about the most reactive metals, so you will say group 1A, and most reactive non-metals, so you will say group 7A. Okay, group 7A. And all those elements which are in the center, they are basically unreactive, or you can say they are more unreactive. Okay, Now, elements in the same group have the same number of electrons in their outer shell as we discussed in the last class. Like for example, the elements in group 1A, they have 1 electrons in the outermost shell. As you can say, this is lithium, this is sodium, this is potassium. I have discussed this in the last topic. So if you have not watched my last video, so you can go and watch it. Group 2A, they have 2 electrons in their outermost shell. Then we have group 3A, they have 3 electrons. Group 4 have 4 electrons in their outermost shell. The elements of group 5 have 5 electrons. Group 6 have they have basically 6 electrons, and so on. And in the outermost shell, okay, which is also called valence electron. Periods, basically they show the number of shells. Basically, if elements belong to first period, so it will have only one shell. If the elements belong to second period, so it will have two shell. As you can see over here, in the first period shell there is 2 electron, and in the second shell there is 1 electron. And if the elements belong to period 3, so they will have 3 shells, and if the element belong to period 4, so they will have 4 period. For example, magnesium. Okay, let's just talk about magnesium. Magnesium, its atomic number is 12. So it has 2 electrons in the first shell and 8 electrons in the second shell and 2 electrons in the last shell. So there are basically 3 shells. There are basically 3 shells. So it means it belongs to period 3. It belongs to period number 3, and it has 2 electrons in the outermost shell. 2 electrons in the outermost shell. It belongs to group 2. It belongs to group 2, as you can see over here. It belongs to group 2. So I hope you have find this video very helpful, and I will meet you in the next video. Till then, take care. Allah Hafiz.